Okay, let's do this question with numerical problem, which will let us know the basic concept of electromagnetic waves and the various terms that are related to it. The question says, calculate the wavelength, frequency, and wave number. Wavelength, frequency, and wave number of a light wave whose period is 2.0 into 10 to the power minus 10 seconds. In order to understand the question better, let's draw a picture of wave like this. Since it is a light, it is an electromagnetic wave. It will both have a electric and magnetic field propagating parallel perpendicular to each other. What has question given to you is the time period. So what is the time period? I'm representing time period by t. It means time taken to pass one complete wave a point. Suppose this is one complete wave. The time taken by this wave to pass this point completely. That is called time period. Or from trough to trough, or from crest to crest, time taken to pass through a point from trough to trough, or from crest to crest. Crest to crest is also known as the time period. So it takes, for one complete wave to pass through a point, it takes 2 into 10 to the power minus 10 seconds. It's a very small time, 10 to the power minus 10 seconds. It's very small. The wave is traveling very fast. In this much second, it takes only this much second to pass through, to pass one complete wave to pass through a point. Right, that is called time period. So what will be the frequency? See, if you do not understand what is the time period of a wave, you won't be able to calculate the frequency. Once time period is given, what is frequency? Frequency is again what? In 1 second, or in unit time, maybe 1 minute or 1 hour or 1 second. So since the standard unit of time, the SI unit of time is second. So let's say in 1 second. In 1 second, how many waves are passing through? That is called frequency, and it's given by reciprocal of time period. So time period is 2 into 10 to the power minus 10 second. So 1 by 2 is 0.5. 0.5 when 10 to the power minus 10, it comes above it becomes 10 to the power 10. So 0.5 into 10 to the power 10. If you make the decimal point go one place to the right, it will become 10 to the power 9. Or it will be per second. So this much, 5 into 10 to the power 9 waves in 1 second. Per second is known as hertz. So frequency is 5 into 10 to the power 9 hertz. So it's around the frequency of microwave in electromagnetic spectrum. 10 to the power 14 is visible rays, then comes the microwave, then infrared, then microwave. This segment is 10 to the power 9 hertz, that of the microwave. So what about the wavelength? So now we have calculated the frequency. We started from here. Let's calculate the wavelength. We know that electromagnetic waves, in vacuum, they travel to all the electromagnetic waves from gamma rays to alpha rays, alpha rays to ultraviolet rays to the visible spectrum, then infrared, then microwave, then radio waves. All the electromagnetic waves, they travel at the speed of light, 3 into 10 to the power 8 meters per second. And the relationship between the speed of electromagnetic wave, the wavelength, and the frequency is speed equal to wavelength into frequency. So wavelength equal to speed divided by frequency. The speed is 3 into 10 to the power 8 meter per second. And frequency we have just calculated, 5 into 10 to the power 9 meters. So 3 by 5 is around 0.6. And this will be 10 to the power minus 1. So it becomes 6 into 10 to the power minus 2 meter. So this is also, it corresponds to the wavelength, it corresponds to that of microwave. 10 to the power minus 2 meter microwave. So we have calculated the frequency, we have calculated the wavelength. So what is wave number? Wave number is what? It's a reciprocal, it's denoted by the symbol V with a bar above. It's a reciprocal of wavelength. It means number of waves that are present in a unit length. Say in 1 meter, how many waves are there? So how will you know? It will be reciprocal of wavelength. So wavelength is 6 into 10 to the power minus 2. 1 by 6 into 10 to the power minus 2. When 10 to the power minus 2, when it is brought up, it will become 10 to the power 2. 1 by 6 is 0.1666, so it becomes 1.16. So if we multiply it, it's 16.6 per meter. So in 1 meter, around 16.6 meter, 16.6 numbers of waves will be there. So this is known as wave number. So we have calculated the frequency, then the wavelength, and the wave number. I hope by doing this particular problem, the idea of wavelength, frequency, and the wave number along with time period is clearer.